This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 3 of Week 6, Supportive Knowledge. Electrical Concepts for Mechanical Engineers. You do not need deep circuit theory on this exam. You need the motor essentials: efficiency, power factor, full load current, torque, synchronous speed, and the difference between single-phase and three-phase power. We name each one, then run a clean three-phase input power problem. Two ratios describe a motor. Efficiency is useful power out over total power in, where the 0.746 converts horsepower to kilowatts. Efficiency peaks near three-quarter to full load and falls off when lightly loaded. Power factor is real power over apparent power, kilowatts over kilovolt amperes, and it equals the cosine of the phase angle. Direct current and some alternating current motors run at unity power factor, but induction motors lag, so their kilovolt amperes exceed their kilowatts. Multiply efficiency by power factor and you get apparent efficiency. Full load current is the line current a motor draws at rated load. The horsepower form puts shaft power on top and the voltage, efficiency, and power factor underneath, with a phase factor out front. Direct current has no power factor term. Single phase adds the power factor. Three-phase adds both the power factor and the √3. The 746 converts horsepower to watts. Learn the three-phase form, and you can strip factors back out for the simpler cases. Two more quick relationships. Full load torque is fixed by horsepower and speed, the constant times horsepower over RPM, giving pound-feet. More horsepower at the same speed, or the same horsepower slower, means more torque. Synchronous speed is set by the line frequency and the number of poles. 120 times frequency over poles. At 60 Hz, 2 poles spin at 3600 RPM, 4 poles at 1800, 6 poles at 1200. A real induction motor runs just below synchronous speed. That shortfall is slip, and it is what produces the torque. Real power to a motor is voltage times current times power factor. Single phase stops there. Three-phase multiplies by √3 because power arrives on 3 lines offset by 120 degrees. Use the line voltage and line current, and power factor is the cosine of the phase angle. Real power is simply apparent power scaled by the power factor. That √3, about 1.73, is the single most forgotten factor in three-phase problems. The notation. Real power and apparent power are the two powers. Line voltage and line current are the electrical inputs, and power factor links them. Efficiency, actual shaft speed, synchronous speed, line frequency, and pole count round out torque and speed. Watch the two speeds. The torque formula uses the actual running speed, while synchronous speed comes from frequency and poles. Worked problem. A three-phase induction motor runs from a 480-volt line-to-line supply, drawing 40 amperes of line current at a power factor of 0.85. Find the real electrical power the motor draws. Here is the one-line diagram. 3 supply lines into the motor, line current and power factor labeled, shaft power out to the right. Three-phase real power is √3 times line voltage times line current times power factor. Take the apparent power first. √3 times 480 times 40 is about 33.3 kilovolt amperes. Scale by the power factor. 33.3 times 0.85 is about 28.3 kilowatts. Sanity check. Real power sits below apparent power whenever the power factor is under 1. Exactly the gap 0.85 opens. 4 traps. 1. Three-phase power uses line voltage and line current. Plug in a phase voltage and you are off by another √3. 2. Never drop the √3. Without it, three-phase power comes out about 40% low. 3. Synchronous speed is the no-load speed. A loaded motor runs below it by the slip, so use the actual RPM in the torque formula. 4. Power factor is a fraction, not a percent. 0.85, not 85. Bookmark the motor pages. Efficiency and apparent efficiency. Power factor as kilowatts over kilovolt amperes. Full load current, three-phase form. Torque from horsepower and RPM. Synchronous speed from frequency and poles. Three-phase power with the √3. And the basic circuit staples. Ohm's law, and the power triangle. All of it lives in one short section. Fold those three corners. You now own the motor essentials a mechanical engineer needs: efficiency and power factor, full load current, torque from horsepower and RPM, synchronous speed from frequency and poles, and the root 3 between single and three-phase power. Today's motor drew about 28.3 kilowatts. In topic 4, we switched to materials, stress-strain behavior, and mechanical properties. Different section, same habit. Name it, find the formula, run one problem. See you there.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.